Hello everyone, my name is Skepp. Welcome back to a brand new part 2 because today we'll be doing on part 2 of how to make an automatic train. Which now we'll be making an automatic train system inside of Roblox Studio again because I haven't done a part 2 in a long time. So today we'll be doing on the sections which I have not went through during the whole session of part 1. So today we will be doing firstly on platform screen doors, which are the doors that you see in some games, which doors open whenever the train arrives. Both doors opening, which means that the left and right road open. How far the train will arrive? Around 4 minutes until the train arrives, or like the next train indicators. Then the metro screen door, which will be same as PIDS. The turnaround at depot, which means a new sensor, which they will turn around once they touch the sensor. Automatic train track switching, which is actually a very good idea, which means that they will switch tracks whenever touching the sensor. And the last one will be play sound via engine while touching a sensor, which means that whenever they touch a sensor, a sound will play. So let's get into it. So first thing that you want to do is just get a random train from the category, which our example use this automatic train, which you just have to search up automatic train. You get a bunch of stuff that you can get, but today I'll be using a random one, which will be from this kit that I use sometimes. Then once you're here, you can pick your own train kit. Make sure it's a good one for your own train line. Example, your train line is green, then get a green train. But today we'll be using golden or slash orange, but it looks rather good for me, obviously. Then after that, you could get in your automatic train kit, which I have a specific kit which I use a lot of times, which is made by Mr. Automation Detected. This kit also includes another train, so if you wish to use this train, you can easily color the train by just ununiting the train, or you could just change the color by doing this, but of course the union would not work. So this train will not be used for us today. So you see this now, you could see all of these trains. Example of this is one of the show button, which lets it change tracks. Which this is a very advanced one because this has multiple train switching things, which means that it will take around a long time to script unless you want to just take this kit and just take the script and just rename the script over here. Now after that, get your train and get a random train cart or train kit over here. You will now see over this line, you can just use a plugin, example of Archimedes, and just duplicate the train. The Archimedes plugin is actually very useful because I use it sometimes. Which Archimedes you can see on the left side here. Now you just select your correct angle position, but please note that when you're doing rotation with this, it will look a bit glitchy. So by 0, you can just duplicate it, or you could of course resize the tracks. Now by doing this, oh, something is oh, that's why. Remember to disable this first of all, else it will create a selection bug which will keep lagging you. So once you see the train is aligned with these parts, because these parts are, I'm quite sure, can collide on. Let me check. Yep, can collide on. If you want, these tracks should be can collide on as well, and these walls also can collide on because you're going straight. But if you're going curve, remember that these tracks are always can collide off on the wall that it's turning on the right side, which means it's turning right, the left wall should be can collide on, and this should be can collide off. Same as the left side. So once you try, you can now run the model, which by clicking F6. And you can see the train runs perfectly smooth on the tracks without doing anything. So next thing we'll be using my old video kit, which will be the train speed. So train speed, you could firstly go to here. You can see the if child.name equals station sensor. This is the script where it will detect when a station sensor is passed and it will stop the train. Which you can see here, the train stops because the throttle is now stopped. So after that, you could put in here, after the seat throttle character. Else if child.name equals speed sensor, then this now would do whenever the sensor, if it is a speed sensor, it would change the speed of the train. Seat.max equals to child speed.value. Now what this does is that whenever you pass a speed sensor, there should be a speed value inside it. So example, let me just create a new part and maybe color it to yellow. Now all you have to do is just scale it to a size where you think would be good. Make sure it's in the middle, or you could resize it to the whole thing on your own choice. I'll go doing in the middle and create a part by clicking this button or in the selection below. Change the transparency to 0.5 or whatever you like. You can make it to transparency 1, but it will be harder to find, and turn off the can collide. Rename the part to speed sensor, create a number value inside of it, which then rename it to speed. Now this is how fast you want the train to go. So around, if you want to go around 500 speed, which will go over to basically extremely fast, you could just see. So basically once the train departs, it will now go at the speed, and you could see the train slowly increasing its speed. The train does not change the speed immediately, obviously, because of its throttle. The throttle changes by 1 speed per, I don't know how long, but probably a few milliseconds. So next thing you know, now we will now start on the first thing, which will be platform indicator screen doors. Platform indicator screen doors are quite easily depending if you're doing these platform indicators or platform screen doors. But firstly, obviously, change back the speed to something lower for around 25 for entering station. So you could use a part. So easily you can just take this model, duplicate it, and then hold left alt to be able to do this. Then you have to go down a bit, then try to align it to the correct height of the train. Now you can duplicate this, and this can be our test station. Now for example, you first also need a station sensor, which you can search up very easily by doing a station sensor over here. So basically you could ignore this unless you want to do a specific direction. So basically you just have to do this. Door left would be false if you're, because on the path direction will be doing 0, which means the train will continue going the direction it has been going. But if it's 1, it will go the other direction, or -1, it will still go the other direction. But you can test it out by yourself. Door left would be false because we're going this way, so it's door right. Set line and set name, you can try to play with them, and it will change the title of here above this site destination, showing with the destination. Then after that, put this in the middle of the station, and that will actually work, so that the train will stop over here. Now to test it out, you can simply just click run, and the train will now stop here with its correct door opening on the right hand side. The door will open right side, and you could see that it will have some gap, obviously, because if you don't give it gap and the train enters at a high speed, the train will collide and collapse, maybe if you have a destruction script inside it. So after you're done with that, now you could play with some platform screen doors. So I'm going to do automatic train doors, which you can see from this platform edge doors. You can test it out like this. Now just align this and try to do it like this. And you can see if the door is aligned. Make sure the center, the blue dot, is at the middle of the part. You can obviously just remove this and bring the screen and screen, and find the other screen which indicates the light, which is this one, and just move it. But now door 1, which you see whenever I drag this, there will be nothing over here, so just drag this to the correct position by aligning it to the center, because this should be aligned to the center as usual. So by aligning this to the middle, just aligning the first door to the correct position, and this door should also be aligned, which means that you will have to rescale this part. But what I'm going to do, I'm going to make it a bit more advanced by just changing these parts to be connected to each other, which will be actually a bit realistic. So by doing this, it would make a realism look. So by just colliding this, now you just have to align the door over here, which means you just have to take the screen part, which is this. Then you have to push it all the way to align it correctly. Get the door over here, make sure it does not pass through this, or else it will have a Z colliding fight. then just move this part to where it's designated. Just realign this if it does not work, because obviously you will not get the exact thing the first try unless you are very lucky. So by aligning this properly, there should be some gap over here because I think that is intentionally. So by doing this, you could also experiment with scaling while doing this. What I'll do, if that happens, change the move snap the grid lower, then now you will see the white gap. After that, just make sure that this screen is also aligned so that it would be aligned as usual. So after that, now you can see will work. Just make sure that to make it as best as it could be, make sure that everything is aligned properly and there's not Z fighting anywhere. So now this works. You can now move back the train to the original position you did, aka the spawn or whatever you look to call it. But if you duplicate it, you can despawn it. So you can see that now this has a station sensor in it, which you can simply just rename it to open door locator. Which what happens is that you can delete all of these because this will be very useless unless you do not have a station sensor. Well, now what I would do is that I would just put it over here, and you can see the script wait 30 and wait 25. Now the 25 is how long the door cannot be reopened, which means that there will be a cooldown, obviously, so that the door doesn't spam reopen. Now to check how long the train stays at the station, calculate all of these time. So this will be 21.5 plus 5.5, which is 27, and this will be 30 seconds. So after 30 seconds, close the door. But I'll make it a bit shorter. You can try experiment yourself. So it'll be around 28. So now we can test it out on the script, and I'll do a fast forward. You can see obviously the train doors closed a bit late, which you can fix yourself by just changing this speed counter over here to around 25. But then after that, remember to put this ahead if you had a delay to your train, obviously. And after that, it will work perfectly. And now you have your own train doors automatically. And this is not what I called PIDS or platform integrated door screens. Now next thing we will be doing is turn around that depot or or whatever you like to pronounce it. So firstly, you would now just create a new sensor, which I would be duplicating from the speed sensor around to here, which will be depot sensor, whatever you like to rename it, or reverse sensor. So reverse sensor, now you have this, I would just color it to pastel blue. Reverse sensor, you can now come over to here and just same as the speed sensor, although this will be different. Reverse sensor, rename this to whatever you rename the part. So this will be more confusing. If c dot max, c dot throttle equals 1, c dot throttle equals -1, else c dot throttle equals 1. Of course you need to add a cooldown. db equals true, and you of course have to add a debounce over here. Local debounce. Debounce equals true. So debounce equals false. So here is add back if debounce equals false, then and just at the end just add end. So once it's done, debounce or wait one, debounce equals false and debounce equals false. And it's that easy. Wait 1 second. Now you can test it out the script, but because I want to make it quicker, obviously you can change this train speed over here by just making it so whenever it departs after 4 seconds. So now we can just change this to a random time around 7 seconds maybe. So just 7 seconds and you can click run script, or run game obviously, yep, not run script. Now you can see the train entering the station and will depart quickly. And the underlined door is great. And the door should close earlier because something's wrong with the script. So now doors are closed. Something's wrong with the script, which I think I closed it too late. Which now we can just let it go. And whenever this touches the part, it should return backwards, correct? Now if we duplicate this part over to the middle, it should be going backwards. As usual, going backwards. So you can make an infinite loop. So just go back, forward, and back, and forward and back. That's simple. And the next thing we'll be doing is that automatic train track switching, which will be a bit harder, but we'll still do it anyways, of course. So I'll be just using an example kit over here to show you what it works. So basically, the track switching, whenever this button is clicked, it would change tracks as usual. But obviously, we won't be going that easy. So basically, I'll be using Archimedes for only this part. So around Archimedes, 4 degrees. So you can make it go, and this will be going straight, which means that it will have some colliding, which you can see over here. What I like to do is that I'll group all of the colliding parts and rename it to cross track 1, which is the first cross track. And firstly, you have to remove this because obviously we'll be only using these parts on the floor. So just align it to the part where it will not stick out, so around here. This track will be deleted and this will be aligned to over here. As per usual, disable collision for these so that it can run smoothly without colliding, so it can collide off. Now you can see these track switching parts, which will be the essential parts of what will happen. So because this will be an easy one, only these 3 will be needed to modified. So which means now we can move this to cross track 1. Now you can close all these models, because if these parts are removed, actually, oh wait, never mind. I have to delete this, sorry. So because you see this, now remove this, it will be going straight. Now let me disable this collision, the Archimedes. So this part will be actually also essential, which I'll bring it out to here, obviously. Then now you can rename these parts to L1. This will be also essential for L1. Or you could obviously rename them to left, 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 straight. This part you can also bring it out because it's a little bit essential if you do not want it to glitch, and straight. So basically now what we do is that we could put this to the other side, which is over here and also here. Now this is where the destination system comes handy. Now you could possibly add a value called string, which is destination. So this will be maybe Central City Bank. Now train script over here. You can look at this system. for INV panels too. So you can copy this, remove this because you will no longer need it unless you have set something for a set line and set this over there. Because we will also implement a destination setter soon, which means now we can do this destination sensor, which now we can make this. Now you would want to use the script that you copied just now, not the script, the script which is the for INV and panels do. So this will be child dot set name dot value. So basically maybe changing this color, or you could keep it yellow or whatever you like. I'll be using mint or pastel green, sorry, and change this to a new value called string value and name this set name. So I'll be setting this to City Hall. So speed sensor to destination sensor. Remember to spell it correctly, not like me. Destination sensor, and what we'll do is that we'll be making to script.parent.destination.value value to child.setName.value. Obviously, if it does not pop up, that means that you have another thing that came out, which is destination. You could easily rename this to destination value by just changing to destination value and just tabbing that. So that's how you get the system if you have a destination already inside the module. After that, you should now create a brand new line at the bottom while wait 0.1 or while wait 2. You could just write for INV in Paris panels do now you can remove this obviously, or unless you want to lag it. For INV in panels do panels should be the script over here, which this line child is saying the value. Remove this obviously and change it to script.parent.destination value. Now the text will change to the value. Click run and wait for the text to change, and you could see it not working. If it does not wait, something's wrong. Oh, okay, I see. I know why now. Because this is a new module. So while wait 0.1, you could also add in the system script of parent. So just do this because unfortunately it seems like you cannot do another wait script because something is already disturbing in front. So just doing this, not in service, will be changed to City Hall. You can easily change this, obviously, the font and the color in the inside, and this is waterfront. Welcome aboard this new CC train, which is customizable if you have this train module kit. Then after that, this will be where the destination comes in handy. Which now we have to make an independent sensor, which we can name it sensor detector or track switcher. And create a script. Script.parent.touched connect function part. If part is a driver's seat, then make sure it's called driver's seat, by the way, because I'm not sure. Oh, vehicle seat. That's why. Okay, sorry. Vehicle seat. Okay, now you fetch the train station, which is part.parent, which you have to check where it is. So vehicle seat, which is parent.destination value. So you can add local destination equals that dot value. If destination equals to city hall, then which will check if the destination is city hall, then we'll now switch to inv in Paris game workspace dot track switcher, which is the best part, which was wrong. Wait, you have to find back what you named the model, obviously, which for me I have named it cross track 1. Where did I put? Oh, okay, parent to workspace, sorry. Cross track 1, get children, and you'll see all of these children will be picked. Do if v is a part if v dot name equals to left, then v dot transparency equals 0.5, v dot can collide equals false, and if v dot name equals straight, then v dot transparency equals 0, v dot can collide equals true. So now if it's city hall, then it will turn straight, not right. Okay, sorry. So example, this will be a destination towards Citibank, and that'll be City Hall. So Citibank will just touch this. So by changing the line over here, something is wrong with the script. Please wait. Oh my goodness. So you see it. Convenient. Okay, something is wrong. Oh, v dot name. Is it this? It's wrong. Wait. Close, open. Open. Okay, I fixed it, sorry. Now, if destination equals City Hall, else if destination equals to Citibank, then you can easily copy the script. Equals to Citibank. If parts left to 0 and true, and straight will be put in pipe and false. So this will be towards Citibank, and this will be towards City Hall. So let me get the train ahead. So let's run it. And the train will depart. And this train will be going left, and that train will be going straight. But see, oh, I forgot to make the train a bit further, sorry. So by easily just moving this a bit more forward, so that it will have more time to leave the intersection. So the train will now depart, and you can see that this will be turning left, and this will be going straight. You can see that. Just that, and I just have to fix the distance because of a distance error, which I could easily fix by just moving this train a bit more further. By clicking run, it would now make it so that the train will move smoothly. So this train will turn left, and as per usual, this train will turn straight. And now that train will go backwards. But if this occurs, this means that there's a collision error which you have to fix, which is most likely because of this problem. And now you could get your own functional system easily. So all you have to do is just move this backwards so that it has enough space, and just create another part over here and just fix the missing part over here, and now you're done. Now the next thing to do is that place sound via engine while touching a sensor, which you could easily implement by creating a sound sensor. Which now rename this to sound sensor, and you could insert sound. Now get a random song example of, you can find a random audio. For example, I'll be using Uptown, which is audio. Now that's the audio, so you can change it to purple. Now in here you can write transcript XP, sound sensor, child.sound, wait, local sound equals child.sound clone, sound.parent equals engine, and sound play. Now we can test it out by just going into the train, or you could just do anything you want. So you just have to spawn inside of the train so that you can hear the audio, because it will be moving. Obviously you have to add a cooldown, so you just have to create a new debounce called local stb equals false. So sound sensor, if stb equals false, stb equals true, no doubles, then wait 5 or 3, stb equals false. Then you could possibly make the audio a bit louder, so sound dot volume equals to 2. Now you can just spawn back inside the train by clicking play here inside the Roblox Studio, or you can test it in game obviously. The audio will be playing from the center of the train, and the whole train should be able to hear it. You can change the volume by lower or higher, and this can be how you can export audio to your whole train who plays your automatic train game. And this will be for all today, because this will be the entire video for today. Thank you guys for watching. See you tomorrow.